We are kicking off this afternoon session with a team from Red Hat, and they are presenting an overview of integration strategies between CephFS and OpenStack Manila. Please welcome Goutham, Pacha, Ravi, and Carlos Eduardo da Silva.
Thank you very much for joining us today. So my name is Carlos Eduardo da Silva. Thanks for the introduction. I'm joined by Goutham Pacha. This presentation was also prepared by other colleagues like Ashley Rodriguez. So we'll see a bit more of Ashley tomorrow in the workshop that we'll be doing, like the From Zero to Code workshop, where we'll try to get every single attendee to make their first open source contribution. So please join us on that. And the three of us are maintainers on the for the OpenStack Manila project. We work at Red Hat, and our work is like done mostly on the upstream Manila side of things. So we'd like to chat with you about something that's widely used but kind of misunderstood, and we are talking about CephFS in your OpenStack clouds. So this is not going to be kind of like a very in-depth talk about, like in terms of CephFS. It's more like a one-on-one talk where we'll discuss pretty much how things work, and yeah, you can figure out if it fits your use case, and yeah, including how to set up and how to use it, and how can you integrate with it. So this is our agenda for today. Yeah, first we'll talk about OpenStack Manila and how it integrates with CephFS, and then do a bit of a comparison between native CephFS and CephFS NFS. Now, we have a demonstration and the future plans that we have for the CephFS native and NFS drivers in Manila. So first, Manila, right? So as you might know or might not know, Manila can offer you pretty much self-service POSIX compliant shared file systems. They are kind of elastic and secure by nature, right? By design. So why is elastic? Well, you can grow them and shrink them as long as your quota allows you to do that in the cloud. And they are secure because you can also control the access to it with access control with ACLs, pretty much. So you can control who can read, who can write, and who can mount, pretty much. So in addition, Manila also provides different levels of multi-tenancy. So the cloud administrators can control the storage used through share types. So you can target or define share types with specific capabilities that will allow the shares to be scheduled to specific storage, matching those characteristics. You can define quotas, and you can also control resource visibility for a couple of resources like ACLs if you don't want to leak, or if you don't want to make available CephX user, for example. You can add visibility locks for that. It's a kind of a recent feature, but you can do that with it as well. So it's pretty much, it allows you also to reinforce access control lists. There is a more complicated design or a more complicated approach that you can take with Manila, which is pretty much allowing you to have more isolation over, like the networking, and having with the multi-tenancy isolation, we mean having multiple share networks and then granting the network isolation between the shares and the share servers. But we won't get into that today. So with Manila, you can create multiple shares of multiple NAS protocols like NFS, CIFS, CephFS, and others. And apart from that, you can also have a lot of other day 2 features for maintenance, like migration, replication, snapshotting, all of that. So next, CephFS, right? So CephFS, also open source, which is kind of like an awesome solution for you, because CephFS consolidates block, object, and file storage within the same cluster. So you don't need different storage for that. You can offer the 3 of them, and it simplifies a lot the management of the infrastructure, and it's easier kind of to maintain the cloud. It's also scalable, right? If you need more data, if you need more space, you can start adding more disks to it and it will let you take an approach where you are not locked into a single vendor for hardware. So that's also another very important capability or important thing about CephFS. And at the same time, it's like elastic. It has a very mature quota management system. So yeah, another very nice thing is like crush algorithm, which will distribute your data evenly across the nodes, and there will be awesome balanced load distribution between the clusters, and you can expand them to like exabyte scale. So pretty cool, and I mean all of that with also something being like fault tolerant and self-healing, and as I said, open source. You can also contribute to it. You can help like people take the decisions. So that's awesome, right? So a bit of the timeline of like CephFS and OpenStack Manila. So Manila was production ready in the Kilo release. But CephFS driver was implemented only on the Liberty release. And then we had the CephFS driver only supporting for shares only with the native CephFS protocol. And then the support for CephFS and FS came later, but we'll get to that soon. So back when we added it, what was, or even today, what is a share or a shared file system in the Ceph storage? Well, it is a subvolume within a file system. So it has a quota. You can define a quota, and the quota would be like the size that it would be allowed to grow to. And back to Liberty, it only supported CephFS native shares. In OpenStack Pike, it was introduced the support of NFS shares through NFS Ganesha. And it started, back then we would only support shares for NFS version 4.1 or newer. Next, we had Queens, right? When we had NFS Ganesha high availability added. And then we started, like making incremental additions to the driver. So next thing was like the next big milestone was multi-FS support. So what do we mean with multi-FS support? It means that you can have one cluster that has multiple file systems, and each file system will be represented to Manila as one backend, and then you can create shares in those multiple file systems. And then Yoga, right? We added Ceph, or the Ceph Manager API was replaced by the Ceph Volume Client, and Zed, one of the most recent, or one of the recent additions that we did, and it was like a huge milestone for us as well. You can see more details about that in other talks that we did, one of them at the Open Infra Summit in Vancouver 2 years ago, but pretty much adding support for high available CephFS and FS services deployed by Ceph ADM, and that unlocks like a whole lot of new things for us. It also comes with like the AJ proxy protocol, and later then in the envelope release, we kind of managed to also introduce support for helping you to migrate your cluster. So if you have a standalone NFS Ganesha, then and you are planning to migrate, then you would pretty much be able to migrate, and you can have a period of time where you are transitioning. So you have the standalone Ganesha in the cloud, and then you are moving to the Ceph ADM NFS Ganesha, and then you can just have the two configured to Manila, and then we'll try to represent everything that you should be using. So we'll say, for example, we have like multiple mount pads. One of them is being exported by the standalone NFS Ganesha, and the other one is being exported by the Ceph ADM managed Ganesha service. So, and then we would mark the one that's preferred, which is the one that has the high availability capabilities as the preferred export location, so that people start mounting through that. And yeah, I think that covers a bit of the timeline. So in summary, what is a share in the CephFS or in the Ceph storage? It is a subvolume. and it provisions like subvolumes within a single CephFS file system. And Manila access rules, they will allow the subvolumes to be mounted, and you can configure the access rules. Like for NFS you have IP, and IPs are subnet. And for CephFS native, you have you can deal with the users in the cluster. So CephFS volumes, they can be consumed via CephFuse or kernel CephFS and NFS v3 and v4.1. Support for NFS v3 is going to be a thing in the next Ganesha release, right? Yeah, it is a thing in the most recent and greatest Ganesha release. So yeah, that is available as well. NFS v3 is kind of like a use case where it's mostly targeted for people that have Windows workloads. So yeah, now heading to Goutham to cover a couple of other things.
Awesome, thanks Carlos. All right, let's dive a little bit into the native CephFS use case. This was what the first integration with Manila was. And a bulk of the users back then, and even now, I think the largest deployments of CephFS anywhere, they're using native CephFS. What is native CephFS? Well, as with any, accessing any kind of storage over a network, you have a bunch of work that's being done at the server and a bunch of work that's being done at the client. And in native CephFS, the work that's done on the client is quite important. So there's a lot of enforcement of things like quotas that are actually done at the client level. So you can imagine if you have a distributed file system that's being offered on a cloud, you better trust all of your users and the clients that they're installing, because some of that enforcement could actually be wonky and mess up something on the shared infrastructure. And so that's one of the biggest differences between using native CephFS and gatewaying it with something like NFS, which is becoming increasingly popular, which is such a weird thing to say. NFS is becoming increasingly popular, but in terms of using it in a large multi-tenant cloud that OpenStack clouds typically tend to be, it is a popular use case there. With native CephFS, besides having this trust model, there's also the aspect of extending the Ceph network to your clients. So if you have the Ceph public network, that has to be accessible to your end users. So that could be their user VMs, and so they could directly connect to it, or they could route to it. Except in case of routing, you had to be sure that nothing in the network path is actually going to hinder the performance and so on. But you could typically just put them behind a router as well. And you would be using CephX usernames. And the word of warning here would be CephX usernames that are created by OpenStack Manila are globally unique, which means that a lot of people trip up with this. So you could create a CephX username assuming that, hey, I have a OpenStack user called J. I'm going to create a CephX username called J, except that's now going to be a reserved user on your Ceph cluster. So there better not be another J in a different project, which is not really congruent with the way OpenStack works, really. You should be able to assign users to different projects and so on. But just a word of warning, and the way you get around this is just make sure that the CephX users that you're using are unique. That could just be like a random string that you're generating or a UUID. So besides that, I think, so this networking being an inflexible part of your thing is a big consideration for many large deployments, especially if you're offering a service cloud or a public cloud. You are probably not extending your Ceph public network to your end users because you don't really trust them. So that might be one reason why you're going to consider gatewaying CephFS with NFS. And this, like Carlos was telling you, is getting better and better with newer OpenStack releases and with newer releases of Ceph itself. So right now, what we're talking about, and we've spoken about this a lot, in the OpenStack Z release, we added support to be able to export NFS natively. And this NFS happens to be the NFS Ganesha orchestrated directly on the Ceph cluster. Or you could denote certain nodes and create an active NFS cluster and export via OpenStack Manila. And what that does to you is it increases the availability of the NFS service itself. And it also allows you to scale a little bit in terms of if you have a lot of different users and their shares gatewayed through a single cluster, you now have those serviced by individual servers rather than having all of them gatewayed with one server and you're hitting scale bottlenecks there. And the way internally that works is the NFS service is living on the Ceph public network, except you then allow it to export on a different network. You can isolate that network, you can call it an NFS network, you can extend that to your end users, you can create any number of NFS networks and partition your end users and so on. So that allows you to give your untrusted end users access to their to your Ceph cluster in a better way, in a more secure way. And then there's this aspect that NFS has been around for so long that it's a lot popular. So a lot of client tooling has been around for so long. People understand how it works, and so it's probably more familiar when you're offering this as a service on a cloud, for instance. So that's the deal with NFS. And let's see, we had a small demo at this stage. I hope that. So just shows you a little bit about of the internals on, okay, spinning circles. Yeah, hoping that loads. Oh, it's loading off of the internet. No wonder. All right. All right, hope that's legible. So we're just listing OpenStack Manila services. We're looking at the pools that we have. And in this case, we have two pools, a multi-backend setup, which both CephFS native and CephFS NFS. And we're looking at the share types that we've created. So this is how we're partitioning people on this example cloud. We're going to give some select people access to Ceph native and some others Ceph NFS. And this is what we would do. We've just created a share. That's what the share looks like. And that would be the access control for the share. We've provided access to a random subnet. In this case, a client is probably going to access that share through that subnet. Just means that nobody else has access outside of that subnet. And that's what the Manila side configuration looks. It's pretty boilerplate, pretty straightforward. Manila just needs to know how to connect to the Ceph cluster and what the file system on the back end is called. And when you look inside Ceph, we have two separate file systems partitioned off. And so that comes with its own set of data and metadata pools. And if you're looking at the Ceph orchestrator services, you're probably you're going to notice that each data and metadata pair have their own set of MDS services. And they also have, there's also the NFS cluster there. And then there's a subvolume. How did that come about? Because we created a share through Manila. And that ends up becoming a subvolume inside CephFS and all of the goodness out there on how to use that with the subvolume interface. The funny thing about this was not too long ago, this really nice Ceph CLI didn't exist. And it's getting better every day. So here's a NFS export that Manila created. When you set up that access rule, that's what it looks like. That's the client rules that it's applied. And that's how access control is done from an OpenStack cloud into a thing. So as you saw in the presentation, you could, let me just switch back into the presentation, if that's possible. Oops. Sorry for the hiccups. Let me just. Oops. Did I just kill the presentation? So that was the short and simple of how things work in the cloud once you've set things up properly. Let me just do that. Yeah. So what's next? What is the Manila team working on, and what's the CephFS team working on? Well, right now, for the last few releases with the OpenStack Nova team, we were working on VirtIOFS, and that's now available with the epoxy release. Except if you're looking for a Manila CSI integration, that's not there yet. So that's coming soon too. What does VirtIOFS do? So a lot of people find that adding NFS gateways in front of CephFS is not really performant or scalable to their cloud needs. And so they were looking for something like VirtIOFS, where the mounting of CephFS is hypervisor mediated. So it looks and feels a lot like Cinder volumes. So you can trust your compute nodes. And so you'd give them permission to mount your CephFS and then expose it as any regular file system inside a guest kernel. And so that's possible from the epoxy release if you're interested. And we're also working on CephFS via SMB for folks that are bringing in a lot of Windows workloads from VMware. This might be of interest. And the NFS Ganesha community is working on adding QoS controls to NFS Ganesha. So at an export level, you can specify QoS controls for bandwidth and IOPS. We're also working on Barbican integrated user-defined encryption. So you can encrypt your CephFS volumes along with managing the secrets of this encryption via OpenStack services. And on the back end, the NFS Ganesha team is working on auto scaling and recovery. So today, if you shoot one of the Ganesha servers down, there's a particular process of recovery that ought to be followed through a manual recovery, and that should be getting better. So there's this auto scaling work that's going on, but it's slow at the moment. And finally, Kerberos. I think this has been on the wish list for a lot of people with respect to NFS. So that's something that we'll be integrating with OpenStack Manila. With that, that's the end of our presentation. And I guess if you have any questions, we'll take them now. Thank you.